Hey guys, welcome back. So last week I pulled the rear wheels off of my 1953 Ford Golden Jubilee. It's an NAA Ford tractor. And I pulled them off to put new tires on it. While I was there, I figured I would put new brakes on it too. Well, one of the things I noticed was, and it's a problem they have with these machines, is that this is the housing that goes on the end of the axle that captures the roller bearing, and you shim this side so you get the proper end play. Well, the bolts that go through actually go through the front. They go through here, then go through this, and go through into the axle housing. They break. The heads break off them. Okay. They shear. It's hard to get that to focus. And this isn't a real backing plate, but really more of a shoe holder. So this is mounted on here, and then the shoes are mounted on here. And everything's bolted through here, or these are pushed through with nuts on the back side. Well, they break, and when they break, this is allowed to twist and swim. And the first problem with it is worn really bad in the center hole. The other thing is this has been a problem for years. It's a few times this has been fixed. The back side, you can see where it's really gouged this up bad, right in here. Everything's backwards with the camera here, right over here. I was going to plug weld these, bore this out, put a ring on the outside of this that would fit the new bore. And then I found this online, a brand new one, for like, I think it was $120, 120 bucks. So I ordered 2 of them. So that project's out the window. Thank God. Because lining this all up so that it sits where you want it to sit in relationship to the outside of the drum and everything when you don't have a lot to indicate off of, I had an idea how to do it, but it was going to be a big deal. Well, this also has been wallowed out. Holes have been oblonged, but if you flip it over, they're really not bad at all. And if you look at the axle housing, they're beautiful. I actually checked them. They're still round. They're not oversized. Why? I don't know, but it really made a big difference right here. So my plan of action is, obviously, I'm getting new plates. I measured this, and it's about 4 thousandths out of round, which really should not be that big of a deal. I'm switching from these factory bolts, which don't have any, they don't have hex heads on them. They're just rounded, and they have a knurl that allows them to kind of press into that plate to keep them from turning when you torque them. I'm going from this cheap ass bolt, and I'm going to put 8 grades in there. And there's plenty of room for the heads. Why they did not do that right from the get-go, I do not know. Because I can torque them up better. So what I'm going to do is I'm going to drill these out. One of them is a thread. So one of them locks in. There's a thread in here, and it has been helicoiled. And it's only helicoiled halfway. I'm going to helicoil it all the way. Then what I'm going to do is I'm going to indicate this in 2 of these that are good, really good. And then I'm going to come in and I'm going to take an end mill, and I'm just going to touch these to take the pattern draft off, because this is cast. Once the pattern draft is off, I can turn it in the vise, and I can hold it this way, drill these, and ream them. Okay, so I got a drill, and I got a 19/16 reamer. These are 7/16. I'm going to plug them. I'm going to do a light press fit with Loctite, and then I'm going to re-drill them 7/16. Okay, and the reason I'm going to square these ends off is when I indicate these two right here square with each other on the y-axis or in line, I don't want to drill into this only holding this on 2 points and it's tapered. So I'll clean this up. I'll go nice and light with the end mill, make a nice surface, flip it, and I'll be able to do my bolt pattern. It is a 5 1/4 inch bolt pattern. So we'll do that with the DRO, and I'll chamfer them first. So if there is any run out at all, when the drill comes down, it'll have a nice place to sit, ream it, press them, re-drill them, and this should be good. Okay. The last thing I'm going to do is I'm going to set this up in the lathe, and I'm going to face this off because this has been rocked a little bit. So I'm going to take about 10 thousandths off it, and they sell shims for this too. I don't know why, but this just sits on here and holds the shoes, but obviously if you go too far in, the shoes wouldn't be in line with the drum. So I'll try to get a 10,000 shim, or make a 10,000 shim, and I'll bring that back up. I'll measure this, we'll bring it back up to height. So that is the project, the new project, to complete the last project to complete the tire install. Okay. Like I said, these NAAs, 8 ends, 9 ends, they all use basically the same braking system. In fact, I know the 9 ends and the NAAs, they all use this plate, this design, and they all break these bolts, and they still sell these bolts. They do not sell this. So worst case scenario, I plug these and re-drill them, I put it back on the tractor, and it breaks out. I will get a piece of Durabar and I will make this over. Okay, I don't want to have to do that, but I will. It's really not that complicated of a part. I mean, obviously it won't have all these cutouts. These were just done to save cast iron. It'll just be a round piece. There's nothing in the way. There's no clearance problems. This was just to save cast iron. So I don't think it'll be any worse than what it was, because the 9/16, I measured it off the area that was unworn, and it looks like it's going to clean it up with no problem. And it's already this big, so it was stopping the tractor. The pedal was a little bit low because it was shifting. This is a mechanical braking system. So I think it's going to work. I am going to thread this all the way, and then what I'm going to do is, there's supposed to be a bolt threads in from the back. It looks like it was supposed to be threaded on this side too. It's got a hole in the plate, so I'm assuming it's supposed to. So I've got 4 7/16 20 by 3/4 bolts. One will come in this way, one will come in this way. Then the rest of them will be through bolts. All right. So the next time you see me, I will be on the Bridgeport lining this up. Find 2 of them that'll line it up dead square to the X and Y axis. Mill these flats, flip it over, and proceed to do my bolt pattern. I'm going to use this bearing to indicate it in true, because that should be the truest spot on this whole hub, although this outside is really good too. But I think it's going to come out all right. So next time you see me, I will be at the Bridgeport. Okay? See you in a few. All right, we had to regroup. I could not hold this on these edges right here. As soon as I tighten the vise, it would start rocking. So I went with the center pull down. I got a piece of very hard bushing material, which was very square. Put that under here. I indicated the surface, which it's within a couple thousandths all the way around. And then I put some, I put a clamp on here, and I measured the side of the bolt from side to side. This one's threaded in. This is just setting in there, but clamped down tight. And I even reclamped it like 4 or 5 times, and it always goes back within 1/1000th of where it was sitting. So I'm pretty good with where that's sitting. These are going to be 7/16 holes. There's plenty of clearance in this bolt to begin with, so I believe it's going to be all right. So I'm going to come in here with an end mill, and I'm just going to touch this each side to square it up so I can put it back in the vise and I can get a real good clamp. The only problem with doing one clamp in the center is the tendency to want to spin. So I might put something over here on the flat so it can't, but I got this really tight, so I don't think there's going to be any problem. All right, I'm going to be very light with it, just enough to clean this up. I don't care if they're both the same size. I just want them flat. Okay. All right, let me set up the rest of the machine, and I'll bring you in when we mill it. It's right on 0. I'm within 0.5 which is far more accurate than this needs to be. I just need to be pretty damn close to the center line of those bolts, because when I put it in this vise, I'm going to indicate in the housing anyways. The only thing that could happen is it could be twisted just a little bit, but you wouldn't even know it when it was finished. Okay, I'm ready to set up to roughly find the center of this. close to the center. I'll bring you back when I'm set up for the indicator. Alright, so this is going to be relatively hard for you to see this, but so what I'm going to do is I'm going to zero one of these. When I say one of these sides. Just tapping the quill down a little bit. And the only reason I'm not using the knee is the tripod's in the way. So I'm zero. You don't want to put any pressure on the quill because we don't want to get a false reading. So I'm going to come all the way around. And it's telling me I'm one off. I'm one fat. So I'm heavier on this side. So I got to shift it a 1/1000th and I have to pull it to my right. You cannot see that. I don't know if you can see that. I'm a half on that side. So that's directly split in half. Now I'm going to come over to here and I'm going to see where I am. And this is not going to be perfect. It's not perfectly round. So over here I'm plus 2 2/10. And over here I'm plus 3. So between 2 2/10 and 3, I'm going to split that, which isn't very much. So I'm going to unlock my Y, and it is going to move a little bit. And I'm going to split that difference. And I'm going to lock my Y, which is going to make it move just a tick, about 1/10. Alright, so I'm about 2.5. Three. I could do just a tick more, couple tenths. So we're 2 7/10. And we're 2 6/10. That's close enough for what we're doing. Now, just for shits and giggles, I'm going to put this on the outside and see what it is. Alright? I'll do that off camera. So I'm pretty damn close. I mean, maximum out 4/10. That's good enough. Okay? There is a little variation between this bearing race and the outside, but this is a used bearing, so there is going to be a little bit of wear on it. But I'm happy the two of them pretty jive within a 1/1000th. Okay? Now, if for some reason I milled these flats a little bit off parallel with these two holes, that's really not a problem for a couple of reasons. Number one, if I shifted these over 3-4 degrees, it's not going to make any difference at all. I have a worn hole. I just don't want to get too close to the edge, so I don't really want to be off too far. And actually, they drilled them off a little bit. Number two, when I set up to do my PCD or my bolt circle, I can put in the DRO, I can change it by individual degree increments, so that if I come over here and I did number 1 and it was off 2 or 3 degrees, I can change that. Okay? Alright, so I'm going to get set up to do that PCD, and I'll show you how to do it. Alright, so we just indicated in the center of that hole, that barren race and the outside diameter. We're going to set this up to do a bolt pattern, a PCD, pitch diameter circle. How you do that on this DRO could be a little bit different than another, but usually they're pretty close to the same. So we're going to come over here to the icon, PCD, X and Y. We're going to hit enter. Our center point is where we're located right now, 0, 0. Our diameter is 5 inches, 0.250. Enter. So 5,250, 5 1/4. We're going to do 6 bolt holes. Enter. Our starting angle is going to be 0 on this particular setup, the way it's set up. If we wanted to skew it 60 degrees, 30 degrees, whatever the case is, this one, a half a hole would be 30 degrees, a full hole would be 60. But we're going to start on 0 because our 0 line is lined up dead straight with our x-axis. And our ending angle is going to be 360 back in that number 1 hole. If you were going to offset that, let's say 30, you would add 30 to the 360, which would be 390, and you would punch that in. Okay, so it's going to tell us our first hole, because we're lined up with the X, we just have to come over to the side, but Y is where we want to be, right on the center line. And once we get there, this will read 0. And we move to our next one by pushing the arrow down. 2, again, go 0, 0, X, Y, and advance until you finish. And on this one, it will tell you over, done. You can go back by just pushing the up arrow. Okay? All right, so we're all set up now, and we're going to proceed to chamfer these holes